So the problem that we're going to answer today says the figure at right shows one of the many rectangles that can be inscribed in the ellipse 4x squared plus 9y squared equals 36. The first quadrant corner of this rectangle is 1.8, 1.6. Find the dimensions of the inscribed rectangle that has the largest area. It is not the one shown. So in order to do this, we want to maximize the area, which means that we need to graph this. So the first step to doing this is you want to draw it out and give the intersection a point. So we're going to name the point xy. And by doing this and labeling our rectangle, we can see that the length of the rectangle will be 2x and the height will be 2y. So the area will be 4xy, but we need it to find it in terms of one variable. So in order to do this, we're going to use the equation of an ellipse and solve for a variable. And in this case, we'll be solving for x. So the first thing you want to do is subtract 9y squared on both sides in order to get 4x squared alone in order to isolate x. Then you want to divide by 4 on both sides. And then after that, you want to square root it in order to isolate x, and you should be left with x equals the square root of 36 minus 9y squared over 2. So now you want to make sure to take the positive amount because we're looking at a length and you need a positive length. And then this is just because you always have a negative and positive value whenever you're square rooting a value. So now what we want to do is substitute this x value into the area formula that we have. So the area formula that we have is 4xy, and so what we want to do is substitute our value for x. So now you should be left with 4 with the square root of 36 minus 9y squared divided by 2 times y. And now what you want to do is graph this value. So when you graph this value, it should look something like this. And now you only want to consider the positive x-axis, which is this right here, because you want a positive length. And you also want to keep in mind that y is the variable in the equation. So technically when looking at the graph, x is y. So this graph here is saying that the max area is 12 when y is 1.414. So now the next step is you want to plug 1.414 into the ellipse equation in order to find the x value. So here you can see that we're plugging this in and then solving this so that you get 4x squared plus 17.9946 equals 36, subtracting this value on both sides in order to isolate x. And then we are dividing by 4 on both sides in order to get this value, x squared equals 4.50135, and then square rooting this value in order to isolate x, and your answer should come up to be x equals 2.122. And so when you plug the x and y values into the area equation, which can also be written as 2x and 2y, this will give you the dimensions of the rectangle. So by plugging in these values, your dimensions are 4.244 by 2.828, and this would be the dimensions of the biggest rectangle that you can fit.